Solve the following system by substitution. So when solving a system using substitution, you ideally want one of the equations in the original system to have a variable solved for or by itself. Here, we don't have that in either equation. So we're going to have to rewrite one to force it to have a variable to be solved for or by itself. Now, there's not a right or wrong answer of which variable you choose for which equation, but looking at the first equation, I'm noticing all the coefficients we have -3, and we have constant of 12. So I believe that solving for a variable, solving for y, is going to be the easiest, fastest way. So I'm going to take the first equation and solve for y by adding 3x to both sides. So -3y equals 3x plus 12, and dividing by -3. So y equals -x minus 4. I can now take that expression and substitute it in for y in the other equation. So that would give me -4x minus 7, not times y anymore, but -x minus 4 equals 7. Now we'll solve for x by distributing the -7. So we'll have positive 7x minus plus 28 equals 7. Then we will have to combine our like terms. So -4x plus 7x is 3x plus 28 equals 7. Subtract 28 from both sides, giving us 3x equals -21. Divide both sides by 3, so x equals -7. Now, let's take that value that we just found for x. We have x equals -7, and we're going to substitute that into one of our original equations. So I am going to choose the top one. You could choose either. So I'm going to choose, I'll rewrite it, -3x minus 3y equals 12. And we're going to substitute that x is not x, but now we found that the value is -7. And now we can simplify to solve for y. So -3 times -7 is 21, minus 3y equals 12. Subtract 21 from 12. Subtract 21 from 12. So -3y equals -9. Divide by -3. So y equals 3. Combining our two values we found into an ordered pair would be -7, 3. And looking at our answer choices, that makes our solution B.